Okay, welcome back. How was holiday break? Good. Are you excited to be back to school? Yes. I am very excited to join you today. We're going to do some math together. How's that sound? Are you ready? Are you awake?
Yes.
Well, we'll make sure we get you good and awake before we start thinking deeply, okay? Okay, so what do you notice? There's a photo of my family. Because sometimes when a stranger comes in front of you, right, you might have some curious questions about who is this person and why are they here, right? So I like to get that out of the way first so you know a little bit about me. I'm a teacher, just like all of your teacher friends here, and I teach math, and that is my family up on the board. I have 4 children, and their names are Hannah, Grace, Charlie, and Angela. And I came to you, does anybody know, did your teacher tell you where I came from to come visit with you for today? No? Nothing, right? Okay, so I came to you from Pennsylvania. Do you know where Pennsylvania is? Yes? In the United States, in America? Yeah? It took me 2 airplanes to get here. And how many hours? Maybe 7 hours? About 7 hours of time flying to come visit you, right? How lucky am I to be here with you? So that's a little bit about me. Now what I like to do before we get started, sometimes you have a question that's burning inside of you. I'm going to give you an opportunity to think and let me know, is there any question you have for me before we get started? Anything you'd like to know? One friend in the back. You guys have a question? Yes, go ahead, my friend.
What is the household and the background?
Ah, that is an excellent question. Excellent question. It's actually a pretty famous place where we are that lots of people know about and lots of people go visit. Does anybody recognize that? Can you maybe see what that might be? That's a terrific question. Good noticing. Anyone? What do you think? You think you have a guess?
I think maybe there's some wars were there
Some wars? What makes you think that?
because it looks like it's a little bit like the Charlie.
Excellent. It looks a little bit destroyed and it might have been fallen down a little bit. Good. She's on to something. Anyone else have any? Yes?
A castle.
A castle? It does kind of look like it could be part of a castle.
A temple.
A temple. Those are all excellent, excellent guesses. So let me tell you where that is. Are you familiar with the country Italy? Italy in Europe? So my family and I went to Italy, and that picture is in the Colosseum. Have you heard of the Colosseum? Did you learn about that? The big circle structure with big archways, right? And battles used to go on actually in the Colosseum, right? So that's where we are in that picture. Good noticing. Okay, so this is 3rd grade, yes? All right, so when a new person comes to visit you, sometimes it's important, and you guys are so attentive, and I really appreciate that. But it's important for you to know just a couple of things about what really matters to me as your teacher for just this next hour. We have about an hour together, and I want to share just 3 things that are really important to me. Can you stick with me for 3 things that I hope we can do together while we do math? Right? So my first is to ask you a question, because that's what my first thing is. Do you think when you do math, do you think math thinking happens quickly or slowly? Slowly? Everybody agree? Does anybody disagree? Anybody? No, we all agree? Excellent. So that's my first, is that I think math thinking takes time, right? I know my brain sometimes takes a little bit of time to think and read and maybe think about my answer before I give it. So I want us to all remember that. That's one of the things I'd like you to remember. My expectation for you is that you think that math thinking takes time. And my second expectation kind of builds on that. What does that say? Who can read that for me? Yes, my friend.
No arms in the air. Why it saying so?
Excellent. Excellent, excellent. So one thing that I like to do when I do math class to allow my friends around me to think is that, you know, sometimes when you have an answer, you want to let your teacher know you have an answer, right? And you know what? You know what sometimes people do because they're so excited? What do? I know. And do you know what that does to the person next to me or next to you? What might that do? Be a little bit distracting, right? If I'm still thinking, it might be distracting. So it's really important to be kind to our friends around us and give them time to think. So I'm not sure what kind of symbol you give to your teachers when you have an answer, but I would like for today, and this might be a little tricky because it's going to be different maybe, instead of raising our hands in the air, it says no hands in the air, I would like you to put your hand here in your chest, right? So here, so it's a little bit quieter. Right? It's a little bit less distracting, so maybe my friend next to me, instead of me waving my hand around, if I just quietly put it here, I can see it, that you have an answer, but it'll still give our friends some time to think. Do you think we can do that? Okay. Everybody try that? If I have an answer, my hand goes. Perfect. All right. Those are my quiet signs, and the last thing I want to say is it's really important that we listen to our friends. So when I ask for an answer, I would like everyone to listen carefully so that we can hear what they're saying, and that just one of us, unless we're doing group talk, which we will, are talking at a time and the other to listen. Is that fair? Are those fair expectations? Maybe you've already done these with your teacher? Yeah? Okay, terrific. Okay, so, shall we warm up? Do you know how to add? Of course you do. You're in 3rd grade. So here's what I'd like you to do. Before I do math, I like to stretch. Everybody stand up. All right, I'd like you to get with a partner. For an example, how many are we? 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. Is that right, teachers? Teacher? There's 19 here today. So one of you will be my partner. Who's missing the partner? I know you have partners, yes? Is that true?
Right now, they didn't have their 10 partner, the one beside them, or?
Anyone beside them. Okay, terrific. So will you be my partner for my example? Here's what I would like to do. There's this little game I like to do to get my brain thinking, okay, and get my body moving. And I want you to try it for a couple of minutes, and we're going to add, right? So we're going to start slow. One hand behind your back. One hand is my machine. Are you ready? This is not a race. This is not meant to be fast. It's just meant to be fun and to get our brains thinking. So, my friend, what we're going to do is we're going to count 1, shake up your machine, 2, 3, and on 3, we're each going to shoot a number with our fingers. 1, 2, 3, shoot. And we're going to take turns adding that number together. Can you add that? What did we make?
7.
Excellent. Ready? 1, now it's my turn. 2, 3, shoot. 4. 1, 2, 3, shoot.
9.
Beautiful. 1, 2, 3, shoot. Ooh, it's my turn. 5. Sorry. Does everybody got it?
Yes.
All right, so let's get our brains thinking. Let's start with one hand. Even though I think this group can probably do 2, we're going to get to that. Ready? Everybody turn to your partner. Take turns. Remember, this is not a race. Just add the numbers and get your brains working. Ready? Are we ready? Everybody turn to a partner. Turn. You go that way, my friend. Uh-oh. Let's see. 1, turn. Good. All right, everybody turn to a partner. Are we ready? You don't have to go on my time. You can go on your own, okay? Because everybody's going to take their own time. Ready? All together now. 1, 2, 3, shoot.
10.
1, 2, 3, shoot.
5.
Ooh, 3. 1, 2, 3, shoot. 1, 2, 3, shoot. 8. 1, 2, 3, shoot. 2, 3, 2, 3, shoot. Oh, you got it. All right, how's that going? Easy? Too easy? All right, let's put both hands into it. Are you ready? 2 hands behind your back. You ready? 2 hands into it, and we're going to add the sum of all of the fingers together, okay? Remember, not a race. And you check each other, right? So make sure, partners, keep your other partner honest. Make sure they're getting the right answer. All right, are you ready? Ready? Go. 1, 2, 3, shoot.
10. 14. 17.
1, 2, 3, shoot.
20.
8. 1, 2, 3, shoot. Good. 1, 2, 3, shoot. 9, 11. 1, 2, 3, shoot. You're good. 2. He is. Who's? I want a new partner. He's too good. He's winning over here. I'm getting them wrong and he's getting them right. 1, 2, 3, shoot. 10. 2, 3, shoot. Excellent. 2, 3, shoot. Look at what I did. I gave myself 4. How's it going? Good? Do you feel warmed up? Does your brains feel like they're working? Yeah? Are we ready to think? Excellent. All right, let's have a seat. That's a little stretch for your brain. Does it feel like it's ready to think now? All right, terrific. Now, I'm putting some thoughts on this slide today just to make sure I'm clear and to keep us on track. So you'll notice that I'll move through some slides. So I have, the topic we're going to talk about today is fractions. Have you heard the word fractions before? Yes. Okay, so then we're going to have a little discussion. I want you to remember that when you have an answer, I would like our quiet sign, okay? So my question to you is I would like you to tell me everything you can, everything you know about that. Everything you know about that. Did everyone hear what he said? Tell me what he said. It means half. Very good. What does that mean? Beautiful. Did everyone hear what he said? It was a little bit quiet. Did everyone hear that? I'll say it again. He said that when you have a, it means when you have a circle and you can draw it in half, right? That you take one of the two pieces. Is that kind of what you said? Yes. Okay, so he's picturing a circle in his mind. Very good. Tell me something else about half.
Like when you're measuring, you can say like this is instead of 4 centimeters, you can put 4 centimeters and a half.
Ah, okay. So my friend over here was picturing circles. You're picturing measurement, and he's saying I can go 4 centimeters, and then I can go a half more. So we can use it in measurement as well. Very good. How about something else? Yes, my friend.
It's like 1 out of 2.
Ah, 1 out of 2 what?
Pieces.
Pieces. Okay, pieces of what?
Fraction.
Fraction pieces. Okay. Of what? What might that 1 out of 2 pieces? You're correct. What might they be out of? Yes.
A half of something like it could be any shape.
Any shape that is whole, right? A fraction is a part of a whole. My friend over here imagined his whole being what? A circle. And my friend over here imagined his whole being what? Measurement, or a centimeter, right? Okay, tell me something else. I have one over here. Tell me something else. Come on, there must be more. Yes,
They have 2 symbols.
there's 2 symbols. Okay, can you tell me what they are? What do you mean by that?
Like there's, you can like draw it differently or sketch it differently.
The symbol for a fraction? You can sketch it differently. Is that what you mean? How would you sketch it if you were to sketch it? Okay. Ah, so you're saying, I see what you mean. describing the symbols, that you can write it horizontally, right? Instead of one on top of the other. Anyone else? Anything else? Yes, my friend.
You can divide it like the numbers, like if you have 20, and you divide it in half, it equals 10.
Everyone hear that? So I don't have to just take half of a circle, I can take half of a number as well, right? Very good. All right, next one. Tell me everything you know about that. Yes?
That there is one shaded out of the 3 pieces that they are there.
There's one shaded out of 3 pieces there. Very nice, thank you. Tell me something else. Tell me something else. Yes, my friend.
That's a fraction.
That's a fraction as well? Very good. What kind of fraction is that? 1 out of 3 is shaded. So it's another way to represent a fraction. Something else. Yes?
They are all equal parts.
It's like you're reading my mind. That's the one I was thinking of. They're all equal parts, right? Did everybody see that? They're all the same size, right? And shape inside that fraction. So a fraction is equal parts of a whole. Does that make sense? And in our example there, what is our whole? A circle. Very good. Very good. All right, you're good. Next one. Tell me something you know about that. Something else, right? Tell me something else. There's more. Who hasn't talked to me yet? Go ahead.
It's 1 out of 3 too.
Oh, that's 1 out of 3 as well? Okay. 1 out of 3 as well. Does everyone agree with that? Yes? Very good. So that's 1/3 and that's 1/3. Do you agree with that? Okay, tell me something else. Yes, my friend.
They are also equal parts, each of them.
They're also equal parts. Good noticing. They are equal parts. If they weren't equal parts, would I be able to name it as 1/3? No? Very good. Show me now I want you to raise your hand. Do you agree if they weren't equal parts, would I be able to name it 1/3? If you believe the answer is no, raise your hand. Does anyone believe the answer is yes? That's a lot of pressure, right? Everybody's hand went up. Very good. All right, excellent. So you know a lot of things about fractions already, I would say. So we know that it's a part of a whole, and we know that they have to be what kind of parts of the whole? Equal. Very good. All right, now let's get our boards. So now you're going to show me. I just gave you some examples. Now I want you to show me. Are you ready? Can you draw a model of that fraction for me? I'm interested in your answer. Tell me about it. Let's look at our friend's answer. Show everybody what you did. Different, right? All right, talk to me about that answer.
It's 1/5
Very good. So turn that around again and show everyone. So my friend over there did 1/5, and he drew a circle. And how many pieces did you cut it into?
I'm going to find 6.
Oh, oh. Oh, see how fast he fixed it. Why did you change it?
Because I first didn't count it well, and then you told me, and then I counted.
Very good. Very good. So tell me, what does that bottom number represent to you? What does that bottom number mean?
The 6 triangles that I cut it out in one circle.
Very good. The 6 triangles that he cut it into. Now, what is different between your picture and the picture I asked you to draw? Are they the same or different? But guess what? Was his fraction correct? Absolutely. So that's a pretty great mistake, actually. It's not a mistake at all. It's just not the fraction I put on the board. All right, look around. Terrific. We have some rectangles, some squares, some circles. Shaded in half. Yes? All right, very good. We're going to finish getting warmed up here and move on. Ready? Now show me 1/3. Beautiful. Now, somebody who drew a circle, tell me about why you chose a circle and what was difficult or easy about that for you. Who chose a circle? That's okay. I think it was you I was thinking of. Go ahead, tell us about drawing a circle.
It's because you have to either here, like there is some triangles, and plus this is the top. You just do one triangle, like the other one, and the other one, and then here's the section.
3 pieces of triangles inside the circle. Now, my friend over here, I saw you started with a circle and changed. Is that accurate? Why did you change? You liked the rectangle better? How come? Bless you. Very good. Did everyone hear what she just said? I noticed she started with a circle, and it's a little bit tricky to divide that circle into equal parts, and she was sort of thinking, well, it's not really, they don't look equal to me, so it was a little more obvious. She used the word obvious, so she chose a rectangle. That was a good change in your strategy to make it more clear. Did anyone else have a struggle making them equal parts? Equal parts is important, right? All right. 1/4. Very nice. Take a look around the circle. See who maybe did one similar to yours or different. I'm making any cool mistakes again? That's my friend back there with his own fractions. Ah, okay. Very nice. Very nice. Excellent. All right, last one. Are you ready? You guys look good. Oh, There. Sorry, there's one more after this. I'm gonna see if I can get you. See if you can make you think a little bit more, because this seems a little too easy for you. We're gonna make this brains work. You are you sure this is third grade? Yeah? Okay. How are you doing over there? I can't see your coloring. Is your marker not cooperating? Anybody struggle with this one? No? Excellent. Excellent. Let me see. Two. Okay. Some chose circles, some chose rectangles. I see a different shape over here when you did 1/4. All right. All right. Last one. Small shapes might help. Unbelievable. Beautiful work. Was that tricky? All right. All right, so let's move on, right? Let's move on. I'm convinced you know enough about fractions to move on. Here's what I would like to do. I would like you to, we're going to pass these buckets around. I would like you to grab, let's have a little geometry review. One of these, what shape is this? Hexagon. I would like you to grab one of these. I'm going to put them up on the board so that you have them. One of these, what shape is this? Rhombus, beautiful. And one of these. You're good. All right, pass it around. We're going to take one of each of these, and then I want you to take 6 of these triangles. Got it? All right, somebody tell me what I just said. What did I just say? Yes, my friend.
You need to take 6 triangles.
6 triangles. What else did I say? Yes, my friend. Excellent. 1 hexagon, 1 trapezoid, 1 rhombus, and 6 triangles. Ready? Go. Yep. Around and start doing your bag carefully. So I thought it might be fun to look at fractions with some other shapes. You all seem to have circles and rectangles pretty figured out. So let's play with some other shapes. there's nothing quite like making a picture with shapes. Or a tower of some sort. So like that. Nice. All right. Are we ready? All right, so here's what we're going to do. I would like you to take for a moment, let's focus, on just the trapezoid and the triangles. And I would like you to play with those a little bit and tell me what you find. Just the trapezoid and the triangle. What are you finding? Let's see. Some of you are building and creating. What are you finding? Yes.
I found out that 3 triangles makes 1 trapezoid.
Oh, that 3 of your triangles makes 1 trapezoid. Is that true? Can everybody verify that? Show me.
Here.
Ah, okay, so you're already thinking about a hexagon, but let's think about the trapezoid. How many people found that 3 triangles makes a trapezoid? Can you show me? Did everybody get that? Interesting. So look at my question on the board. What is the triangle called as part of the trapezoid? I want everyone to think about that. Think about that and give me a quiet sign. What is the triangle called as one part of the trapezoid? What do you think? What is the triangle called as part of the trapezoid? I'll say it another way. If the trapezoid is your whole, what is the triangle called? If the trapezoid is your whole, what is the triangle called? I just heard a moment of over here. If the trapezoid is your whole, what's the triangle called? Ah, some of you are writing. Yes, my friend, in the back corner. Yes.
A quarter. It could be a quarter or a third.
It could be a quarter or a third. What do we think about that? Is it a quarter or a third? How many triangles did it take to make the trapezoid? 3. So 1 triangle is called 1/2. Okay. Let's think about that. Do we all agree? Are you fixing your answer? Do you wanna do over? Yeah? She thought about that as soon as I drew this. Tell me again, what is 1 triangle? 3 halves? Well, let's think back. Let's think back to our fraction and what you told me in the beginning. You told me that the bottom number represents what? The denominator, do you know that term? We didn't say that term yet today. Do you know the term denominator? You all know so much about fractions, maybe I took it for granted. The denominator, what did somebody tell me that denominator represents? Tell me. I have someone here.
The pieces, how much the pieces there are.
Excellent. Did everyone hear what he said? He said how many pieces there are, how many pieces we cut it into. How many pieces did we cut? Did we divide? We didn't actually cut, but did we divide this trapezoid into? How many? Count with me.
1, 2, 3.
3. If somebody stacked, like I did, 3 triangles, so we divided into 3. So what is one of those called? Yes, my friend. 1 out of 3. So the triangle, as part of the whole, if our whole is the trapezoid, is 1/3. I want you to raise your hand if you agree with that. Do you agree with that? Yeah? All right, let's try this again. So the triangle is 1/3 of the trapezoid. Can we agree to that? All right, so now I want you to focus on the hexagon. And I want you to play with just the triangles and the hexagon. And maybe you'll see where this is going. And tell me, he's already working on this one. Tell me what you see. Give everybody a moment. And tell me what you see. You have some thoughts? The triangles and the hexagons, what do you see? I see over here that it makes a perfect flower, right? Beautiful flower. What else do you see? Who wants to tell me? What do you notice? Who hasn't talked to me today? Have we talked today? No? I'm so happy you're talking to me. Go ahead.
6 triangles make a hexagon.
Ah, so 6 of the triangles make the hexagon. I'm having some issues here. It fell off. I didn't put it on my pocket. Sorry. Okay. He said 6 triangles can make the hexagon. Did everybody else find that? All right, so that's interesting. So now let's think about our fractions. So what is the whole in this example? What did you use as the whole, my friend? Which? Did I do that wrong? Yep. Oh,
What do you say?
sorry. See, this is why. Thank you. I don't know, I was on my way to an octagon, I think. Okay. What's the whole?
The whole is the 6 of the triangles in 1 hexagon. The whole is
Which shape did you divide up into triangles? Like up here.
the hexagon.
Beautiful. The hexagon, right? So this is our whole, and this is our part. And in the hexagon, when the hexagon is the whole, look at our question. What is the triangle called? If the hexagon is the whole, what is the triangle called? My friend. Beautiful. 1 out of 6. Raise your hand if you agree with that. 1 out of 6. Do we all agree? Does anybody disagree with that? It's fair. We can disagree in here. We're all friends. No? We all agree? All right. What am I going to say next? Take a look at the rhombus. Good. Take a look at the rhombus and the triangles. Tell me what you see. It's easy. Easy.
I've got 4.
Thank you. Does anyone not talk to me today? Talk to me, my friend. I came all the way from Pennsylvania just to talk to you. What is 1 out of 2? Good? Beautifully. He said that beautifully, but he said it nice, real quiet. Did everybody say that? 2 of the triangles he was able to make the, what shape were you making? The rhombus. I know. Yeah, cats get your tongue. Yes, the rhombus. So, if the rhombus is the whole, what's the triangle called? What's the triangle called? What is the triangle called as part of the rhombus whole? Is anyone left who hasn't talked to me? Go ahead, my friend.
1 out of 2.
Beautiful. A triangle is called, we can name it 1 out of 2, or half, right? We used those words before, half, third, or 1/6, right? Now, let me get this straight. Take a look at what I drew over here. So you're telling me, with the trapezoid, we call the triangle what? 1/3, 1 out of 3. With the hexagon, we call the triangle
1 out of
1 out of 6. And with the rhombus, we call the triangle. How does the triangle get so many different names? How could that be? Think about that. How does the triangle get to be 1/3, 1/6, and 1/2? Why does the name of the triangle keep changing? How we call it, how we name it as part of the whole. What do you think? I see a couple of answers. Does that seem weird? Does it seem a little strange? No? He's saying no. It makes no sense. Why?
Because it's the smallest shape there is. Because right, it is in 3. It's in 3. And it's the smallest shape there is.
Okay, I hear what you're saying. He's saying of all the shapes, it's the smallest, so I can fit it into. I'm going to rephrase. You mean you can fit it into the other shapes? Yeah, okay. So it can be part of each of the other shapes, right? But why does the name keep changing? Why is it 1/3 for the trapezoid, 1/6 for the hexagon, and 1/2 for the rhombus?
Because the shapes over here have like 3 sides, like the hexagon have like between
The middle one?
yes, because the hexagon have 6 spaces for the triangle, and
based on the what? What's based on? Very good. That's an interesting noticing. Did everybody hear what she just said? That the trapezoid we can call 1/2 of the hexagon, right? Very good. We can fit 1/2 in. So, folks, the triangle keeps changing because the whole keeps changing, right? As the whole changes, it all depends on the whole. And I want you to remember one thing when you move forward with fractions and you do other amazing things with them. I want you to remember that it always matters. You always want to know what the whole is, right? When I asked you to name the triangle, you needed to know what whole I was talking about. Was I talking about the trapezoid as the whole, the hexagon as the whole, or the rhombus as the whole, right? Right? All right, I have one last thing that I'd like us to do with fractions. That was awesome. You guys are awesome. I want you to go to your neighbor and give them a high five right now and say, way to go, neighbor. Way to go, neighbor. And then I want you to give yourself a pat on the back. And I want you to give everybody around you a round of applause for being awesome and working hard and thinking hard. Now, I have one last thing for you to do, and I want you to talk to the person next to you. You don't have to move. And I would like you to tell me, based on what we've talked about today, I want you to take a look at this image and tell me, what does this picture show you about fractions? Or, I'll say it another way, and I don't want you to answer me yet. I want you to talk to the person next to you and tell them. I'll say it another way. What fractions do you see in this picture? Right? So 2 ways I'm saying that. What does this picture show you about fractions? Or what fractions do you see in this picture? Please take a moment and turn and talk to your neighbor next to you about what you see. We all finished at exactly the same time. Where did these, are these like the best students in the whole school?
Of course. Sorry.
Where did you come from? I want to hang out here more. All right, well that was pretty magical that everybody stopped at the same time. So in your pair, somebody tell me, what did you see? What fractions do you see in this picture? And if you need to come up to show us, that might be necessary. So let's start with this pair back here. Go ahead. Are you together? Who was with you? Okay, very good. Can you both share with us what did you see?
That guy is 1 divided by 4. 1 divided by 4.
You see 1/4. I'll restate when you look at the kite, right? Can you tell me why?
Because there is one shaded of 4. There is one shaded of 4.
One shaded of 4. Who else saw the kite as 1/4? Let me see. Who else saw the kite as 1/4? I know this is not a question. I just want to get affirmation. Interesting. Okay. So other people. Did anyone see the kite as a different fraction? Maybe. Take a look at that kite. My friend over here saw 1/4. What did your group see?
1 out of 3.
On the kite? Where did you see that?
Because
Can you show me?
like it's like 1 out of 4.
Oh, you did see 1 out of 4. Okay, now you see it differently. Did anyone see something different? Yes, my friend.
We saw the Ferris wheel. It's a circle divided into 10 pieces, and 2 are shaded.
Can you come show me those pieces?
Up there.
Mm-hmm.
And where the lines are of the outlines, they're divided into different triangles.
Okay. In the Ferris wheel circle.
Yeah.
And how many parts, how many equal parts do you see? That's a tricky one. How many equal parts do you see? 2? So you see it as the bottom half and the top? Where do you see 2?
From the 2 parts and the top part.
1, 2, 3, 4.
The ones that are those 2 big triangles on the top.
Up there? Okay, very good. Can everyone see what she's seeing? So my question with that is, they have to be equal parts, right? Do we agree on that? Can we cut that circle into equal parts like that?
No.
What happens, my friend, when we get down here? Do these look equal? Yeah, they get a little bit wonky, right? They get a little bit crazy down there. So maybe not, did you say 10? You counted 10 when you divided them all up? Right, but maybe they're not 10 equal parts? Do they look like 10 equal parts? Okay, that's a good mistake though, because that's one that I make a lot, is I forget to remember that they have to be equal. What might that Ferris wheel be, if we want to focus on the Ferris wheel for a minute? Go ahead. You found another one. Okay, go ahead.
The balls in the kite
Ah,
look like a rectangle. It's 4 out of 1.
the bows.
Oh no, 1 out of 4.
Ah, interesting. You're seeing these? And you're seeing 1 blue out of 4. What's different about that fraction that he saw? What's different? That's a little bit different than the fractions we've talked about. What's different there? Go ahead, my friend.
They're not like together, they're not separated.
Ah, they're not together, right? They're not one whole. It's part of a set of the same. These are the same, right? They are the same shape, but they're not one whole, right? That's a different way that we can look at fractions, as one of these 4 bow ties. Very good. I'd like to go say though, let's focus on that for a minute, right? If we accept that we can have part of a set, what's another fraction that I can use? Which part are you seeing as shaded? Who just told me about the bow ties? He sees the blue as being the shaded bow tie. But what fraction might I see if I see the red being the shaded bow ties? Then what fraction is it? Think about that. Take a look. What fraction of that set is it if I'm focusing on the red? So my friend over here saw 1/4. What else might you see? Go ahead. 3 out of 1. How many are in that set? 1, 2, 3, 4.
4 out of 1.
How many are shaded? Are you looking at the red? 3. Good. And let's go back. Remember, that bottom number, right, is how many are in the whole set. And this is a little bit, this is not what we did today, but how many are in the whole set? How many bow ties total? 4. And how many are shaded? 3. So it would be 3. Beautiful. Thanks for the help. 3 out of 4. So think about that, and let's go to one last thing. So let's go back to that kite, because somebody told me they saw 1/4 on the kite, right? 1 out of 4 on the kite. What might another fraction be for that kite? What if somebody saw it differently? Different shading, what might it be? Now the kite is what we worked on today, right? Part of the same whole. So what might the other fraction be? Yes, my friend. Ah, can everyone see that? If I'm naming the yellow parts, it might be called what? 3/4. But if I'm naming the red part, I might call it what? 1/4. You guys are very sweet. So let me ask you today, how do you feel? after a big yawn. Let me ask you this. Was anything today, I don't want you to think about this because I want a real answer, so let's hear it. Was anything today challenging for your brain? Did anything slow your brain down and make you think? Think about that. I see some people nodding, but I want you to think about that. Did anything slow your brain down today and make you think? It's hard to tell with you guys. You're on the ball. Is that a yes or a no? It's a yes? Tell me, what slowed your brain down and made you think? The Ferris wheel. I would agree. Did the Ferris wheel slow people's brains down? Right? What is the most important thing when you look at that Ferris wheel to remember? What kind of parts do you have to divide the whole into? Equal parts. Very good. What else? Anybody else have something slow their brain down? And make you think? Do you have something? I can't tell where that hand is. No? Do you have something? No, thank you. Go ahead.
When you set out the goals, you could change them to 3 hours, 4 hours, and 1 hour.
Yeah, I think that was a little bit of slow too, because we were working on parts of a whole, right? But believe it or not, this is yet to come, but fraction can also be a part of a set, right? Which can feel confusing and slow your brain down because they don't necessarily have to look the same anymore, right? Which makes me think that I would even be able to see more fractions in that picture if I thought about it that way. What was easy peasy today? Give me one more thing. Put your hand on your chest if you have something. What was like, oh yeah, Dr. K, that's so not, hard for my brain. What was really easy for your brain today? Yes, my friend.
Fraction 1 out of 1.
Oh, the fraction. And I really thought I was going to get you with that. I thought I was going to slow your brain down. The fraction 1 out of 1. What else? Give me one more thing. Anything else felt easy peasy? Go ahead, my friend. 1 out of 3 was easy for you. Excellent. Uh-oh. Excellent. All right, ready? One more time. I just want to say, you guys are awesome. Give your neighbor a high five. You worked hard today. I'll give you one. You worked hard today. You are awesome. Give yourselves a round of applause. Come on, let's go. All right, awesome. All right, thanks for spending time with me. I think, I don't know where the place to go back. Uh-oh.
The best I can remember bag work.
Okay, thank you. If you can remember, if you took it out of the bag, put them back in a bag. If you took it out of the bin, put it back in a bin. There's no